Number three is the most widely seen error that occurs during a survey operation is personal error. Errors may occur due to the carelessness of the survey members. Actually, if somebody has taken the readings wrongly, if somebody has not laid the chain line properly along the required line, due to lack of proper alignment. So basically, this kind of errors are human errors, and they occur due to carelessness of the surveyors. They are basically of two types. Number one is compensating error. If an error occurs in both the directions, then they tend to compensate each other and it does not affect the resultant of the work. That means the final result of the work is not affected by this error. So what does it mean actually? Suppose we are measuring one square in the field. The square is ABCD. A is the starting point. From A to B we are measuring, and during that measuring operation, suppose there is an error of 5 millimeter. This is millimeter. 5 meter error cannot occur. Suppose I am measuring from A to B, and this distance is suppose 10 meters, and I have made an error. I made a mistake, and I have made an error of 5 millimeters. Just like that, from B to C there is an error of again 5 millimeters. From C to D again there is an error of 5 millimeter. From D to A again there is an error of 5 millimeter. So what is happening is that in this direction from A to B there is an error, but this error of 5 millimeter is compensated by this error because it is in the same direction, in the opposite direction. So one direction there is another error, and the opposite direction there is another error. So it is about plus 5 and minus 5. Ultimately the resultant is 0. Again from B to C there is an error of 5 millimeter, but in the opposite direction there is again an error of 5 millimeter. So ultimately the resultant error is 0. So in this way, if the error occurs in both the directions, it is occurring in this direction also, it is occurring in this direction also. So they tend to compensate each other. So ultimately the final measurement of the square is not affected. So that is called compensating error. Number 2 is cumulating error. If an error occurs in only one direction, then this type of error may affect the resultant severely, and it is called cumulating error. So if the earlier one is that we have seen errors in opposite directions also, so they compensated each other. But what happens if the error occurs in only one direction? Suppose the starting point is A, I am measuring from A to B, there is an error of 5 millimeter. From B to C, there is an error of 4 millimeter. From C to D, there is an error of 7 millimeter. So ultimately what we are doing is that we are making doing the survey in one direction only. So these errors are increasing. 5 millimeter plus 4 millimeter plus 7 millimeter. Earlier it was in the opposite direction as well. So it was compensating. The opposite direction errors were compensating each other. But here there is no opposite direction. The errors are occurring only in one direction only. So ultimately there is a total of 5 plus 4 plus 7, 16 millimeter error. It is not a case of compensation. So it is called cumulating error. It is not occurring in two directions, it is occurring only in one direction. That is why it is called cumulating error. And it may affect the resultant. That means the final result from A to D is affected by 16 millimeter.